when people join, they don't see the links. So I'm going to share my screen now. Hi, everyone. Thank you for joining. I'm going to wait another minute. You see my screen? I see a like. If you can send me a like and you see the screen correctly and nothing else, no emails, no. It's very unsettling not having the view of the screen in the room. So here again is the collaborative notes and the slides for this session. And if you are in the collaborative notes, you can start writing your name in the participants list. And we will start in a second now. So I have a question here that if we want email addresses, no, not necessarily. If you want to join the interest group, you can join it on the RDA page, and then you'll get all our emails where we update you on the activity of the interest group. So that's it for this question, and I'm going to start the presentation. Hi everyone, and welcome to our session. We are the software source code interest group, and today we have a very interesting session about scholarly infrastructures and quality requirements of software source code. Let's start with a few housekeeping advices. So we have the collaborative notes and the slides. I will put it again in the chat. So as I said before, please add your name to the participant list. If you have a question, you can put it in the chat or the Q&A. It might be easier to answer on the Q&A than in the chat. Raise your hand if you wish to speak. I don't know if you can raise your hand here in Juno, so that's more a Zoom kind of requirement. And please be aware that the session is recorded, and if you are speaking, that we have you on camera. So let's go start. We have a full agenda for you. I'm starting with a small introduction to the interest group for people that are just joining us today, and to kind of see what happened the last few years, because we started a long time ago. And I'm going also to give you an update of the ongoing work of the group, of other groups, working groups. Then we have a very interesting presentation by Roberto Di Cosmo about the EOSC SEARS report. EOSC is the European Open Science Cloud, and SEARS is for Scholarly Infrastructure for Research Software. Then we'll have an update of the activity in the 411 Software Citation Implementation Working Group by Neil Chu Hong. Also very interesting activity there. And after that, we prepared for you a mini workshop session on code quality. And we'll end up with some next steps for this interest group. So let's dive in. The software source code interest group. So we have a nice set of chairs. Thank you for the co-chairs for being our chairs. And we also want to take this moment to thank Mingfeng Wu, which is stepping down from chairing the software source code interest group. With that, we have still with us Neil Chu Hong, Julia Collins, and Roberto Di Cosmo. We have a new TAB liaison, Gretchen Green. Thank you for being our liaison. And I'm your VP 17 coordinator. I'm Warren Greenpeter. I'm a software engineer and a metadata specialist for the Software Heritage initiative. I work at the INVIA Research Center in Paris, France. And I'm kind of dislocated at the moment. So if you have trouble seeing me or seeing this presentation, please let me know in the chat so I can kind of give the hand to a backup chair. So the objectives for our session for this interest group is discussing research software inside RDA. This was the first interest group which came up with this very interesting subject, which is really needed when talking about that data. And the issues that we are discussing here are management, sharing, discovery, archival, and provenance of software source code. And you might ask, why software source codes? Software source code is very special, and this is why we need to take care of it. As Lance Schustek said, source code provides a view into the mind of the designer. The knowledge of the data transformation is in the code, and the essence of the software idea and functionality are written for humans to read and to modify, and only accidentally for machines to execute. So it's very important that source code stays in our minds as something that we need to take care of. So in this interest group, we had many events. If you see my slide, and if you kind of want to see it larger, you have this little icon to expand the screen. You might follow along and see all these events where we did participate and we did meet. And we also had 3 virtual events in this last year. From this software source code interest group, we have launched 2 working groups, one that ended its work, which is the software source code identification working group. We finished the work with a very lovely output about the identification of source code. And we also launched from this interest group the FAIR for Research Software working group. And it is still working, so you are very welcome to join the discussion on that working group. Other related working groups here on this slide are the software citation implementation working group, which Neil will talk about later on, so I'm not going to say anything about that. And we also have very nice related software session in VP17. Sorry, that's a typo on the slide. So those sessions here below are at this plenary, and some of are already are already behind us, so you can just go watch the videos, but they are very interesting sessions to look at. I want to take just a moment to discuss the FAIR for Research working group as an ongoing other activity on software that is happening now. You can join this working group. It was only endorsed in September 2020, and it has already started work on subgroups and a range of different activities. We had a very lively discussions with many controversies and disagreements on FAIR and software. And we're just now working on the first draft of the FAIR principles for research software. So if you join this working group, you can join the discussion as well there. So that's it for the first part of this session, which is the introduction and kind of the ongoing work. I'm going to ask you to go to the collaborative notes. I'm going to post again the links to it and get you into an icebreaker question, which is our first activity here today, to kind of tell us, why are you interested in software source code? Why are you here in this session? If you are not part of the interest group, kind of share with us on the document. I'm going to go see what your answers are, and you're going to see that with me because I have it on the same tab that with the presentation. So bear with me a second. I'm going to go here and show you a little bit where you should answer the first question, if it works. There are many people on the same slide, I think. That's why I can't kind of see what's happening. Excellent. I see that you get the gist of answering the collaborative question on the icebreaker question. I'm going to give you another minute to see all these beautiful colors complete their answers here. And after this minute, I will stop sharing my screen and give the hand to Roberto Di Cosmo. So I'll go and stop sharing my screen, which is up.
Okay.
And hi, Roberto.
Hi, Imran. Nice to see you. So we'll try to play the same game. So let's see if you see my slides. Is it working?
I can't see your slide now. I don't know why.
Can you see my screen? Ah, no, yes, wait. I need to say share. Share, fine. Is it working now?
Yes, now I see it. Okay, great. I'm going to turn off my camera and see you in a bit.
Well, okay. So, hi everybody. It's a very big pleasure to be here virtually with you. My name is Roberto Di Cosmo. I'm Director of Software Heritage. Actually, you will have a little piece of my CV in the slides that are shared already, so I will not spend time on who I am. This is just here to tell you a bit more where this information comes from.
Roberto, you have
yes?
we are seeing the speaker view, so the slide is a bit smaller than we want to see when we look at the screen.
Sorry.
I know it's that's
it's kind
problem
of annoying.
which...
Let me do it again. Okay. Okay.
Yes,
Thanks a lot, Moran, for helping me out. Okay, is this better?
Yes, excellent. Thanks.
Okay, I'm skipping this. I was saying today, the idea is to share with you a short summary of a big effort that has been done inside the EOSC initiative, the European Open Science Cloud Initiative, from a task force, a working group, which was called the same name as the report. It was SEARS, for Scholarly Infrastructure for Research Software. This task force has been led by José Benito González from Zenodo, CERN, and myself, together with some 20-something participants from partly from the EOSC and partly from representatives of key infrastructure that are already today dealing with the issues related with handling software, in particular source code, in the scholarly world. So on the center here, you can see it was archives, publisher, and aggregators that were convened to work together to produce this report. For archive, we had HAL, which is a national open access archive in France, Software Heritage, which is a universal archive of software that I'm directing, Zenodo, which is a very famous cross-institutional archive where you can also deposit software today. So you see 3 different kind of representative archives with very different perspectives. Then we had 3 representatives of the publishers. You had DAX-Tool, which is a very well-known open access publishing community in Germany for computer science. We had eLife, which is a very important publisher for open access publisher for life sciences, and IPOL, which was a groundbreaking journal for actually publishing results in image processing with a full source code and demo and reproducibility and all the bells and whistles we would all love to have in our world. And then we had 3 representatives from the aggregators, that the aggregator kind of search engines, catalogs. So OpenAir, which is a big European initiative that tries to get data from all the around the places. Scanner, which is a kind of OpenAir, but just for France. And SWMath, which is a disciplinary catalog of software for mathematics, which is probably, I shouldn't say this publicly, but I think the best of breed I have seen around for the moment. So all these people have been working together for 6 months at full speed to focus their attention on the needs to handle properly inside scholarly infrastructure software, and in particular software source code. We focused on 4 key pillars, and what we need to provide: archival infrastructure, referencing software, describing properly software, and providing credit to authors. If you look at the report, it is almost 100 pages. Don't be scared. it contains quite a lot of valuable information. Once you remove the bibliography, the presentation of the authors, and tons of use cases, it is not so long to read, and I would really recommend you go there, because you will find the state of the art with best practice and open problems, cross-cutting concerns that were the result of long discussions inside the group with different points of view. Then some plan for a road ahead, requirements and criteria based on real use cases coming from real world experiences from all these infrastructure and more. So you will see more, a lot of workflows, detailed workflows that show you how software can be managed in this infrastructure. And then this concludes with a set of recommendations on standards and tools, policy, some long-term perspectives. So my goal today is, in the case you do not have time to go into the report, to give you at least an overview, so you get probably, to get you to whet your appetite and push you to actually go and read it, if you're okay. So first of all, you might wonder why this focus on software source code, and you have seen already Morana mentioning. So I changed my quotation here just not to repeat. This is from Harold Albenson, 1985. So programs must be written for people to read, and not incidentally for machines to execute. Harold Albenson is a very well-known computer science professor. And the report starts by acknowledging that actually the full issue of reproducibility and sustainability in the software world is extremely important, and it is at the same time extremely challenging, difficult. For reproducibility, for us, is actually predictability in industry, and the people even spending billions of dollars a year have glitches and problems. You have seen in WhatsApp or Google having problems every now and then. So it's not easy. Okay, we are aware these issues are very present in there, but in this report you will not see them addressed for a precise reason. We actually focused only on software source code for two main reasons. One is that source code is actually human readable. So even if you cannot run it later on, if you have difficulty executing it, you can still read it and understand what is going on. It's not easy, it's technical literature, very difficult, but you can. Okay, while with a binary, if you only have a binary, don't have the source, good luck understanding what the hell the binary is actually doing. And the other issue is that handling source code properly is not easy at all. It is a significant challenge by itself. So we decided to focus in this report on how to address these issues in particular, and let's see why these issues are important. So again, here you have another slide that I will not comment too much. I will leave it for you to read in offline. But let me just mention that source code is special not just because it is not just data. It is special also because if you look at software we use in research, it is just a very thin layer on top of an incredible amount of software that has been developed by other people outside the academic world. So the picture you see here, is what happens when you just run Python and type import matplotlib, which is a popular library for drawing pictures, like this one, for example. And what happens behind the scenes, you don't even notice, is that this library is pulling in tons of Python dependencies, that pull in tons of dependencies from different libraries, components, and tons of dependencies of operating system. Most of them were never written for being used by researchers or by researchers. Okay, so the important point here I want to drive in is industry and developer community drive standard, not academia. So we need to take into account this when we do our work. That being said, let me add a little more remarks we made also in this report. Software is complex to handle because you have issues about the granularity, the versioning, the author rows. Just let me give you an example of what this means instead of abstract notions. In a report written from our institution, INRIA, for example, you can find phrases like this one. INRIA created the OCaml programming language and the well-known scikit-learn machine learning library. So here you are mentioning software, but in a very abstract way. Then you can see in a paper or in a document from a research team, phrases like this one. Support for two-dimensional Voronoi diagram has been introduced in the computational geometry algorithm library starting from release 3.10. So again, we are talking about a software, Seagull, but now we mention a particular release. Then you may want to say something. If you really care about reproducibility, just release is really usually not enough. So you need to say what was a precise state of the project. So maybe you find phrases like this result was produced using the software as it was in commit, and then you have a hash out there. Or you can even see mentions of code fragments. For example, this is an extract of an excerpt on a paper that says, the core algorithm we are discussing here is in lines 101 to 143 of this particular file, containing this particular state of a project. So you see the complexity that is going out here, and then it goes worse. I mean, when you look at about authors can have many different roles. I mean, it is not just a developer. It can be the people doing management or design the architecture, or who comes out with the algorithm, who contributes to the testing suite, or, it's not just author or contributor. It's much more complex. So that's the reason why we actually focused our attention on these four key issues: archiving, referencing, describing, and credit. Okay. And let me remark again, I mean, this was taken from a public statement published by the National Committee for Open Science in France a couple of years ago. I mean, when you look at software in research, it can be a tool, it can be a result, I mean, a proof of existence or a solution. So depending on the discipline where you are, you can see a software just as a tool, or just as the result of your research work, or maybe just an object of study, or the three of them at the same time. And so the issue here is not to discuss about what it means for software being fair, which is scoped in another working group. The focus was on four concrete key issues. And these are how to make sure software artifacts are not lost, how to make sure software artifacts can be precisely identified. This is important for reproducibility. How they can be described in a way to make it more easier to be discovered and found, and how to ensure that proper credit is given to authors. Okay, so these are archive, reference, describe, and credit, the four pillars we focused on. In the report, you will see there is a big effort to collect the key requirements to address these four issues, and to address them through an architecture of interconnected existing scholarly infrastructure. Try not to reinvent the wheel, try to connect what exists in such a way to satisfy these needs. So the overall architecture that you will see described in the report looks at the scholarly ecosystem that is exactly composed of scholarly repositories. I mean, you have seen an example of what we called archive in the beginning, publishers and aggregators. And keep in mind that this scholarly ecosystem is just one of the many ecosystems that need to interact with software and source code. And all this is very intertwined. There is no such thing as poor research software. It depends on many other components that come from outside. So you have industry ecosystem, you have public administration ecosystem, you have cultural heritage ecosystems that come through, and we need to interconnect all of them and make sure they all share the same kind of basic archival and referencing standards. And that's the reason we have this layer that's universal software archive, which is today provided by Software Heritage, that allows to interconnect all these pieces of this open architecture. Now you see the blue lines that separate aggregators from publisher and publisher from scholarly repository, and that connect all these pieces together. They are thin lines, but they are very important. I mean, how can these different infrastructure collaborate in an efficient way? So again, all the details are in the report, but let me summarize. So There are short-term recommendations which are very precise. I mean, try to focus on metadata standards and tools. Generalize the use of persistent identifiers, but beware, it is not like the typical case for publication of data. Here we are dealing with software, so we have two kinds of identifiers we need to take care of, extrinsic and intrinsic. I will take a few minutes to discuss this. Then ensuring appropriate credit is given, but this also means beware of not replicating, in the case of software, the disaster we have seen with bibliometrics misused in publication in the past decades. Okay. And then again, strengthening the interaction between these infrastructure. There are also recommendations on sustainability and governance for these infrastructures, including issues related to funding models, so this is not that easy. So I will focus just on some of these recommendations. And then again, I hope I'm starting to convince you it is worthwhile to dig into the report and read it carefully. So for metadata, if you really want interoperability, you need to agree on some kind of standard for metadata. So after discussion, we basically agree in this report there is one sort of standard that is emerging, which is called CodeMeta. I mean, this is an extension of schema.org. It has an extensive vocabulary. I mean, it is not coming out of nowhere. Again, it's an extension of schema.org, which is used worldwide for, I mean, the reason why when I send you an invitation for an event, it pops up in your agenda is that if you look in your email, there is a snippet that conforms to the schema.org standard that actually tells your browser that this is a piece of information about an appointment. Okay, so that's an industry standard. So going there is a very good idea. There is also an embryonic community process. So today we have a vocabulary that is maintained by the CodeMeta group. We also have, luckily, now tools, very easy to use tools to produce this kind of data. This is a CodeMeta generator. And the other standard we are insisting on adopting is following a standard that comes from industry and not from academia. Again, because schema.org again comes from industry, not from academia. This is SPDX, which is a Software Package Data Exchange, which is a standard maintained by the Linux Foundation. So you can imagine that with all the software that runs our society, these people were not waiting for us to tell them how to describe software, right? So there is a standard used by a lot of companies. Our recommendation is not necessarily to adopt all of SPDX, which is very complicated, but at least to refer systematically to the reference of a standardized list of software licenses, which is maintained by the SPDX team. So these are the two parts on the stance, okay? CodeMeta and SPDX. Then about identifiers. I told you here, again, we need to take a little time to make a little bit of distinctions. There are two kinds of identifiers in the world, extrinsic and intrinsic. So extrinsic identifiers are basically system of identifiers that use a register to keep a correspondence between the identifier and the object or entity you want to designate. This is nothing new under the sun. I mean, before the digital era, we had, and we still have, passport number, social security number, ISBN, ISSN, whatever. The plates on your car, all these are numbers or identifiers, but to know who is a person behind the particular person number, you need to go to a register to check whether it is the right person. And you know, it is easy to forge passport number, right? I mean, that is a typical situation. When in the digital era, you have a replication of this idea, I mean, register to keep correspondence between identifier and designated object. The DNS, I mean, the domain name system, that was basic for our internet to work. Then the handle system, the archival retrieval key, the digital object identifier, so many others. So you know them very well, I think. What is less known are intrinsic identifiers. So these are identifiers which are really computed out of the object or really intimately bound to the designated object. So if you have the object, you can compute the identifier. There is no need to have a register. Okay. You only need to agree on a kind of a standard way of building this identifier. And again, nothing new under the sun. Before the digital era, we already had tons of this kind of intrinsic identifier. We just didn't probably realize what it was. Think of the chemical notation, of the musical notation. For in the chemical notation, if I say NaCl, this is a sodium chlorure, which is stable salt. No need to have a register to understand what it is. You only need to know the standard. And you can describe any arbitrarily complex chemical product by just applying the standard. Okay. In the digital era, you have the same idea again, but this came through cryptography. So from a digital object, you can compute a cryptographic signature. This is not new, but has taken a lot of time to actually be adopted. So you have today commit hashes used by tens of millions of developers worldwide, and you have the sorted edge identifier we use in sorted edge to identify 20-something billion sorted artifacts. I mean, again, nothing really new under the sun. It is just a technology that has taken over. Well, if you look at the report, in the extrinsic identifiers world for software, there is a large variety of systems that are already being used. There are communities, for example, in astrophysics, they use something like the astrophysics source code library, which has identifier, extrinsic identifier for software component, has been there for decades. You have Wikidata that is identifying software components, has been identified for a while. You have mathematicians in the SW math that use other identifiers. You have RRID, you have DOIs, you have HAL IDs, handle identifier, R-key identifiers. I mean, a bunch of them already there, already used. And actually, one of the output of the working group, the output of the working group dedicated to source code, software source code identification will give you a nice overview of the situation. The recommendation in the report is that what needs to be done is to actually find a way to be inclusive and to guarantee that the existing well-established extrinsic identifiers are not just forgotten, they need to be taken into account. I mean, how exactly, this is not easy to do, but I mean, that's a basic principle you should follow, okay? Not throw everything out and take account what is already existing. Now, for intrinsic systems of identifiers for software, let me take a few seconds about this. I'm not sure I will do it very in detail. Let's try. I mean, in the world of software development, we have been using extrinsic identifier for quite a while, up to the end of the last century, I would say, with all the defects and problems they have for software. But there was a guy, a very important person, a cryptographer, Alf Merkel, that in 1987 published a nice paper called the digital signature based on conventional encryption function that brought to the limelight a lot of nice technology that you find today in blockchains, distributed file system, and then in distributed version control system, because starting from the beginning of the years 2000, you see an incredible amount of version control systems. Git is the most popular today, but you also had Bazaar and Mercurial and Beekeeper and so many others. They started using this because this enables really distributed software development. The result is that today you have over 40 million software developers worldwide in over 140 million repositories using this kind of technology. Okay, so in software heritage, of course, we did the same. And we picked back on that choice. And this is why we introduced the software heritage identifiers, which are basically, if you see what is happening here, you have a tag, which is the prefix, SWH, that tells you this software heritage identifier, a schema version, a tag for the kind of object which is identified, and the object identifier plus qualifier that gives context. And again, this is included in the software package data exchange 2.2 standard. It is SWH is registered. There is a Wikidata property. Again, so this is not coming out of the hat or nowhere. It is just the way to go when you go in the software development world. When you download the slide, click on this let's try it blue text. It will, behind that, there is one of these identifiers, exactly the one you see here. and you will see how it is resolved in the archive. So I will skip. So the recommendation that you find in the report is, of course, for use intrinsic identifier or for all publicly available software source code, not just research. Okay, all the software you have around. I will skip this slide, and then the last point, but not the less important, is that we have analysis and recommendation about many other issues which are important, in particular quality, curation, and metrics. So you will see that there is a discussion about the different level of review that you can expect about software. So if you look at what the people in the IPOL journal they are doing, this is extremely sophisticated and very hard to do, so we cannot require this from everybody. What we definitely want to require everybody to do is to curate the metadata of software and make sure metadata is valuable and well done. This is easier to do, and we really expect everybody to do this. But of course, this requires providing tools, workflow, checklist, etc., etc. But I mean, that's at least doable. And about metrics, the recommendation again is all kind of metrics we want to see in this kind of architecture of infrastructure should be open, verifiable, and shareable. Okay, so if you say this is 1,000, let me see why this is 1,000. How do you compute it? And most importantly, this should never be reduced to simple numeric indicators. I mean, we have seen the damage this has caused in publication. For a software, it is even worse because there is a huge difference between 20 lines of Python code in a simple paper on machine learning and 150,000 of camel code in a software which is used to verify the control and command system in the Airbus 380 that has been developed over 40 years of research. You cannot say they count the same. Okay, don't use number in a stupid way. So I'm running out of time here. You will see there are also other recommendations on how to actually build tools and connectors to actually make this infrastructure work together. And long-term recommendations about the kind of new technology we still do not have when you actually try to value research software as a result and getting credit. So for example, what do you do about plagiarism? We need tools, we don't have them. We need to build them. We need to have decent search engines and good integration with publication and data. Then you have also general recommendation on how to handle actually these common infrastructure that should be hosted by non-profit organization, not by for-profit. Again, we have seen what it gives in the publication world. Let's not make the same mistake again. And then there is a strong recommendation to try to make open source license a default in research software. Like what we say, I mean, open science means as open as possible, as closed as necessary. We want to see clearly written that research software should be published under an open source license by default. And if it is not the case, there must be a justification. So again, sorry for being a little bit long here, but I hope I gave you some motivation to go read the full report. And now it's time to actually implement this recommendation. If you want to know more, please contact me or Jose. The names are on the report. Thank you very much for your attention.
Thank you, Roberto.
I will stop sharing.
You can stop sharing your screen, but we have two questions for you on the Q&A. I don't know if you can see them. I will try to push them forward to the screen. So the first one is, can you elaborate on no need for a register? There is still a need for a registry. Someone else. Correct.
It has gone up.
Yeah, it's changed the location. Sorry. Yeah. About the registry and the intrinsic identifiers. Can you elaborate on that?
Yeah, sure. But you know, I think I should try to clarify a little bit of confusion that you usually find when talking about persistent identifiers in general. There are two things. One thing is an identifier which is associated to an object. The other issue is how to locate the object. One thing is identifying, the other thing is locating. So intrinsic identifiers do not need any kind of registry to allow you to verify that you have, if you have your identifier, which is mentioned in the paper, and you have the software already that you find somehow, you can check it is the right one. There is no need to ask anybody else. There is no authority in there. Then the question is, how do you find it? Well, but how do you find it? That's another issue. So, of course, you need a resolver for this identifier, some place where you keep the link to places where the object can be found. Okay, but this is not identification. This is location. Okay, and in particular with intrinsic identifiers, for example, when I do distributed development with other developers in the world, sometimes we do not even use a platform. We just send by email. So I send the guy by email this object, and he has the same object as me on the other side. And we are sure we are working on the same status of the software. Okay, if you look at how the Linux kernel development is done, it is still done like this, okay, through a mailing list where you submit the patches in this way. And making sure you're working on the same version comes through these intrinsic identifiers here. This is coming through distributed development. Doesn't mean you do not need an archive. You need an archive, you need a resolver. But that's location in archival, not identification. And so are there...
Great. I have another question here about the recommendation, short-term recommendation. So here is, has this excellent work highlighting important issues resulted yet in any progress on the short-term recommendation and or identification of ways to enable the recommendations in general?
Well, okay. So the report has been published just in December. So don't expect in April to already have a strong impact. There are already a few impacts, that we have identified. Some general recommendation about the open source license, which are easier to apply because this is a policy issue. They are already being taken over. About the interconnections between the infrastructure, there is ongoing work, but we do expect to see in the work by the EOSC, the European Open Science Cloud, to see actually technical real work being done with possibly European funding or in other ways. One good output of this report is that now inside the EOSC, which has now become an independent structure, organization, you have a working group dedicated exactly to see how this kind of recommendation can be implemented. This has been created just a week ago. It's ongoing work. I do hope to see more direct impact soon, but hey, depends on you, okay? You are around the table. It's up to you also to take up all this.
Thank you, Roberto. So there are more questions, but I'm going to stop the questions now in the interest of time, and we will try to answer them in the Q&A and on the notes. Maybe we'll copy that into the notes and try to answer that there. Let's move on to our next part of this session, which is, well, first we have an icebreaker, a second icebreaker, and then we have the lovely presentation by Neil Chu Hong. So first, let me ask you if you are using a scholarly infrastructure for source code. This is related to our presentation by Roberto, and thank you very much, Roberto, for presenting the EOSC report, which is very long and sometimes daunting to try to read. So this is really good to have this first kind of accessibility into this long report and very thorough report. So thank you. And I'm going to invite you all to answer this second icebreaker. So we'll see if you are using already scholarly infrastructure, which are the infrastructure that are you using. This will be very interesting for us to discover later on. I'm not going to say anything else about that. I'm going to leave you a minute to answer, and then we'll move on to the software citation implementation working group update. Let's see if you found the place on the document. So So we are on question 2 in the icebreaker section. I see some colors moving, so thank you very much for your input in this in the document. I always find it very interesting to read and to see which are used. Some are saying GitHub. It is an infrastructure. Unfortunately, GitHub is not a scholarly infrastructure, but it is a good way to share source code. So continue with that great work. And now I'm going to give the torch to Neil to continue with the update.
Thank you very much, Moran. And I'm going to be talking now a little bit about the Force 11 Software Citation Implementation Working Group. So as Moran mentioned earlier, there are a number of different groups that are working in different areas that are closely related to the topics that are covered by the RDA Software Source Code Interest Group. And so one of these is the Force 11 Software Citation Implementation Working Group, which is a bit of a mouthful. It follows on from the Software Citation Working Group, and what we're trying to do in this working group is to produce concrete guidance and guidelines for software citation and see them being implemented in the scholarly research community. So that comprises the software developer community, as well as repositories and registries, journals, conferences and publishers, and indexes and institutions. So if you're interested in joining this, you can go to the webpage on the Force 11 site, and we have monthly calls that are introductions to the area and the work of the working group. And you can also join a number of different task forces that look at specific pieces of work and activities within this space. I'm going to be talking a little bit about the work that's been done by the 4 task forces that have been running in the last year. And if you have any other questions about them, please do put them in the Q&A in Juno, and we will either answer them at the end of this little talk, or I'll answer them by text as we go forward. So for those of you who aren't aware of the software citation principles, these are modeled very much on the data citation principles that were published beforehand, and they identify some key characteristics and attributes of what it means to provide citations for software and why it's important. So the 6 principles are importance, credit and attribution, unique identification, persistence, accessibility, and specificity. And you'll see that some of this work is also filtering through to the other things that you've seen previously, things like identifiers, the reasons why we want to ensure that we're citing software, so to provide credit, and also some of the things that we'll be looking at in some of the questions later, which are around the role of repositories and scholarly infrastructures in this. If you want to find out more about software citation principles, you can find them published in PeerJ Computer Science on the link that's on this slide. So where have we come from and where are we going? In the software citation working group and the subsequent implementation working group, we've been going since 2015 with a group of members who come from all across the different spaces involved in research software, including researchers who are using software and citing it, developers who are creating the tools, publishers and journals and editors who are looking at how this appears in different scholarly outputs, and repositories and librarians who are responsible for curation and understanding how to provide advice and guidance around citation. We reviewed a whole set of the existing community practices and developed use cases, and published this software citation principles document, which includes these different use cases, in 2016. So when the software citation implementation group was started up, the idea was to do what we thought would be the small amount of work left over to endorse the principles and help people implement the principles. Of course, as all of you would probably be able to tell us, a small amount of work is entirely dependent on what you mean by small. And so a large part of this group's work over the last 3 years has been to identify the remaining implementation challenges. So we've got one document that showed the state of where we were in 2018, that's on archive. And as a result of this, we set up a number of different task forces to publish resources on specific challenges, addressing specific challenges. And I'll talk a little bit more about these on the next few slides. Where we're going to go forward now is understanding how software citation fits in with other related work, which is why it's great that we're talking about this as part of the software source code interest group. Some things that you have heard about previously at RDA perhaps are the FAIR for Research software work, but we've also got the question about how software citation fits within the open research and open science agenda, how it benefits and supports reproducibility of research, and the role of infrastructures like software catalogs, registries, and repositories. And so what I'd like to kind of just highlight is some of the things that have been going on that you might find interesting, and what's going to be happening next in case you are interested in getting involved. So the first of the task forces was around producing guidance for different stakeholders. And here we were primarily looking at the sort of people who are creating either papers that are citing software or developers of citable software. We used checklists as a way of providing this guide list because they were seen as the easiest thing to do to provide short guidance that was easy to implement and follow. And so 2 sets of checklists have been published on Zenodo, one for authors and one for developers. And this work has fed into the next, one of the next task forces that I'll be talking about around journals and publishers. So now what we're doing is we're seeing in this task force how the other different groups are making use of this information. And so this task force is on hiatus just now, but it will be reopening to create revisions of these checklists and also potentially to produce a checklist for paper reviewers as well. But I'll talk more about this as part of the mini workshop exercise. Another of the task forces that started off was around repositories and registries, looking to bring together the different people who were involved in managing and curating entries in software registries. And this took the form of a series of calls and workshops where the participants developed and published this paper called 9 Best Practices for Research Software Registries and Repositories. So if you're interested in understanding what different repository managers think are the things that you need to be aware of and do as a repository manager, take a look at this. It covers everything from things like licensing and preservation plans to the ways that you do curation. So this task force has now completed its work, and as a result, it has spun out a new consortium called SciCodes, which is looking to support a community of practice for these registry and repository managers, which is currently meeting monthly. So if you want to find out more about that, you can go to the website for it, which is currently hosted on GitHub, and the link is on this slide. So I mentioned the guidance task force was producing material that's feeding into the next stage of the process, and this is being carried out by the journals task force. So here what we are looking to do is work with the organizations that publish journals, proceedings and monographs to ensure that the way that we are telling authors to cite software in their works is being implemented correctly, and more importantly to ensure that the scholarly communications ecosystem is processing these citations and not losing them along the way. It's called the Journals Task Force, but it also includes things like conferences and basically anything where there is scientific peer review of scholarly outputs that might include references to software. The milestone that we completed early this year was getting a number of different publishers, it's about 20, involved in the co-writing of a paper on recognizing the value of software and a guide on how you cite software. So this is a high-level generic guidance for journals and conferences about what is important around software citation. It's been publicized in a number of different areas and it's got a lot of support from publishers. The next steps for this work are to ensure that different journals, in conjunction with the editors, are able to provide and produce versions of this guidance, which has examples and citation styles that are appropriate for their intended audiences. So turning it from generic guidance into community-specific guidance. And the other thing that we're doing is looking at making sure that what happens after the article is submitted, this scholarly communication workflow, ensures that the citations are processed and indexed correctly, information is not lost, and the metadata is appropriately defined, working with the JATS for our working group, which is a NISO working group that defines the standard for journal article tagging. Finally, the last task force is the Code Meta task force. And this is something working more generally on understanding the metadata needed to describe software, but specifically on updating the Code Meta standard that Roberto mentioned earlier to ensure that we can express all the Code Meta properties that are required to describe software using schema.org, which is a kind of coalition supported by industry to ensure that we have consistent and relatable metadata schema. So there's been a lot of activity in this task force, both reviewing the Code Meta schema and ensuring that we are working with the Code Meta authors to feed into their proposals for the next release of Code Meta, and also preparing formal proposals to schema.org for ensuring that these properties are enshrined within schema.org. I'll also highlight a planned webinar in September, which is going to showcase existing tooling for generating and using Code Meta files, some of which has been described earlier by Moran and Roberto. And if you're interested in that, please do take a look at tools like the Code Meta generator from Software Heritage and talk to Moran if you're interested in finding out more about the webinar. So finally, just wanted to say a little bit about what the next steps for the software citation implementation working groups are. So we've had a number of small successes in raising the profile of software citation with different stakeholder groups, particularly with the help of Shelley Stahl from the AGU, of making sure that we have different publishers on board. Now we need communities to produce their own versions of the generic guidance and promote and incentivize the use of software citation. And here's where you, as the participants of the Research Data Alliance, come in making sure that you're talking to other people in your communities to work out who are the people that need to know about software citation. One of the big challenges is understanding the impact that we're having as this work, because tracking the effects of software citation is a research challenge in its own right. There are whole fields around bibliometric research looking at this. And what we want to be able to do is determine if software citation increases over time. If you're working in this area, there is a recently announced PeerJ special issue that's co-edited by myself and Dan Katz, which is looking for articles on research in this area. And finally, there are still a lot of technical and social challenges remaining. Things like understanding which identifiers should be used for which different pieces of source code and software, and understanding how and where metadata should be stored. So all of this is part of the work of a much wider movement around improving how we understand and value software. And so it links in with a lot of the work of the Software Source Code Interest Group, but also all of the different working groups that Moran mentioned earlier in this session. So I'm just going to stop now and see if there are any questions on the work of the Software Citation Implementation Working Group. So there was something around the links. So yes, the slides, you can see the slides are available on that tiny URL link. So if you want to click on those links, you should be able to do so. I think that's the only question as far as I can see from this. So if you have any other questions, do put them in the Q&A and I'll answer them as we go into the next exercise as well. And if there's anyone who's interested in software citation and wants to find out more about this working group, feel free to either email me or the other co-chairs, Dan Katz and Martin Fenner, or come along to one of our monthly calls. Okay, so now we're going to go into another exercise in the last part of the workshop, where we're wanting to find out some of your views on both code quality and the role of curation and curators on software source code. So what do I mean by code quality? I think one of the challenges of code quality is that it's really hard to pin down how we measure it. I really liked the point that Roberto put up in his slides about the tyranny of numerical metrics. So this idea that you can boil everything down to a number. And it's the same thing with code quality. Code quality may mean different things to different people. It may mean different things depending on the point of the life cycle of the software, its maturity, or the types of users and what they value. One thing that I can say is that there is a difference between software quality and code quality. I kind of, based on an article that's on this blog that I've linked here, I think the general way that we look at the difference between software quality and code quality is software quality is about the functionality. It's around whether or not software serves its purpose well. And code quality is about more the maintainability. So it's does the code serve its purpose well? Is it readable? Is it modifiable? So what I'd like to do is get an understanding from you of what you believe code quality is. So again, in the collaborative notes, you'll see that there is a space for some answers to questions. And what I'd like you to do first of all is just put in what your definition of code quality is. So what are the things, if you were asked to describe code quality to a colleague, what's one sentence would you use to describe code quality? I'll just leave you a few seconds to start looking at that. As you write this, you will get a chance in the next few questions of providing some specific characteristics or attributes that you might consider as part of code quality. So here I'm looking for your higher level definition of code quality. One of the things that I find interesting when we're doing this kind of collaborative note-taking exercise is sometimes you can be looking at people putting in an answer and misreading a partially formed answer. I've just read something where someone was starting to write functional, but I only saw the code is fun, which I think might be an aspect of code quality that we should be enshrining. I think that would be a good one. So there's a lot about readability and documentation, but there's also a lot about how it can basically be understood to do what it should be doing. So I think this is partly around things like verification and validation as well. So whilst we're doing that, I'll also touch on a question that's been raised in the Q&A about what's the roadmap from today's practices to optimal practices. And I'm specifically just going to look at one part of that, which is around the example that the person gives on how we go from the implementation of proper citation practices in journals to where we would aspire to be, given that a lot of software will be, for instance, stored in GitHub or in an institutional repository where the citation metadata is still quite primitive. So I think the thing here is one of the big challenges is that people are not citing software at all. So anything which encourages them to increase the level of information will make it easier for us to get towards the stages that we would aspire to. In an ideal world, we would be ensuring that there were versions of software deposited in preservation quality repositories with good sets of metadata and good sets of documentation. And indeed, that's one of the questions we'll go on to a little bit later. But I think the first step is simply people aren't even, in many cases, giving any indication, sometimes not even the name of the software that they're using in their research, only the type of software. So I think it's small steps. And anything that has an identifier is better than anything that doesn't have an identifier. Okay, I see we've now got a good set of different answers on code quality. So I know that some people have already moved on to questions 2 and questions 3, but what I'd like you to do, if you haven't already, is to start answering what you think makes up the different criteria for readability of a piece of software source code, and understanding whether a piece of software source code is modifiable or reusable. So those are questions 2 and 3. So please go ahead and fill out what you think makes a piece of source code readable and what you think makes a piece of source code modifiable and reusable. Whilst you're doing that, this is a good chance to mention that the part of the reasons why I'm asking these questions is that I am part of another working group called the Code Review Community Working Group, which just got started this year, which is a informal community which is trying to bring people together to develop guidance for code review at different stages of the scholarly workflow. In particular, looking at it for code review during development and what should be done by people who are developing software used in research, and also code review at the time of publication. So what should journals and conferences be doing to help assist their peer reviewers around review of code? We are so new that we don't yet have a website up and running. If you do have an interest in joining in the work of this working group, contact the facilitator and leader, Holly Mounier, to get involved in the group. If you don't know how to get in touch with her or the link in this isn't working, please do again get in touch with me and I can pass your details on to Holly. Okay, so looking at what you've answered around readability, I think one of the things that is coming out is some of it is what you might expect to see in coding guidelines and style guides. So things like how you name variables, how you make sure you are doing inline documentation and formatting, and some of it is around documentation and documenting what the intent of code is. So it's really interesting that there's so much around the way that it's sort of formatted, the syntax of the code. And I think here one of the key things is that this is at least somewhere where we can directly use and benefit from the work that's already been done within different programming languages for doing different types of coding styles. So I'm gonna, I can see, for instance, Moran has put in a lot of really good links that people may want to look at. And there are an awful lot of different people who have looked at understanding different ways of doing reviews of code. I think one of the biggest challenges is how you translate that into a research or academic perspective, particularly given that there may be different limitations on time and different incentives. Okay, now let's take a little look around what people are starting to put in on modifiability and reusability. So some of it is around the structure of the code, so how it reflects the intent of the software, how it ensures that it is testable, how it ensures that it is well described. There is a lot that I would broadly put in place as being ensuring that it is well engineered. And I think also about understanding how things can be used in different contexts and what the constraints are. So I think someone there has put it in as being about the kind of contract that's made. So here, this is also really useful for my work on the FAIR for Research Software working group, where we've been looking to understand how the definition of reusability is different between data and software, and whether the intent of the FAIR principles changes a little bit, or at least the implementation of it changes when we look at software versus data. And in particular, it's really interesting to see a lot of people mentioning interfaces, which is something that we have added into the current draft of the FAIR for Research Software principles. Okay, thank you very much for that. I can see that the editing is slowing down. I think doing these collaborative sessions is a little bit like waiting for popcorn. You don't want to kind of open the microwave when there's still lots and lots of popping going on, but as it starts to slow down, you need to understand when it is you want to kind of move on. So I'm going to move on now because we are coming up near the end of the session, and I'd like to make sure that we're able to do a few of the other questions. So we've talked about the criteria around code quality, but one of the really important things is also who are the people who should be involved in this quality and review process. So I'm now going to kind of open it up a little bit more and talk about both software quality, which is around the functionality, code quality, which is around the readability and reusability, and also the curation quality, which might be something to do with like the fairness of the software or source code. It might also be around the manageability of this. And so what I'd like you to do in the next question, question 4, is just list who you think should be responsible for these 3 different types of quality. So who are the different roles and actors that need to work to improve software quality and ensure software quality, code quality, and curation quality. So you'll see now that there are 3 different columns in the collaborative notes. And what I'd like you to do is just write down the types of roles that you would expect to see involved in each of these 3 different types of quality. And thanks, Moran. Yes, it's now on page 21, if you're going by page numbers. Is it page 21?
Sorry, it was page 16, not 21.
For me, I'm going to be really interested to see what the second role you put in each column is, because I think in general there's a lot of agreement coming in on the sort of primary, the first role that you think about for each of these 3 different types of quality. but I'm really interested to know who you're putting in as the second person. So I see here there's a lot of emphasis here on developers as part of the roles responsible for code quality. One thing that might be really useful to know is, are there particular developer roles that might be taking a larger share of what needs to be done here? So I see, for instance, one person has put in project leader, another person has put in the sort of PI, which I think is really a really good point there, in that you both have the person developing the code, but you also have the person who's effectively leading the project being responsible. Looks like there's a large role on curation quality around the sort of data stewards and repository managers. And I think that is a key challenge that we have, which we'll go on to very shortly, in understanding how repository managers and data stewards are kept up to date now that people will be looking to deposit source code. So I see a question there, which is around what Tom Honeyman has said. When we say responsible, do we mean hold to account or make the change? So here, I guess I'm happy with kind of either that you put in. So I think currently there's a sort of, I think it's more around responsibility for ensuring the change is made, as opposed to the person who is held accountable if the change causes something to go wrong, if that makes sense. So it is responsibility. It's not just the person who's tasked with doing it. It's also the person who is responsible for ensuring it's done. That may have just confused you more. Okay. In the interest of time, and for those people who've now kind of finished off putting in this, I'm just going to kind of go on for the last few minutes onto the final 5th and 6th questions. And what we're looking for now, given what we've been talking about earlier and some of the things that Roberto mentioned in his presentation on SIRS, is specifically looking at curation quality, software quality, and code quality with respects to repositories. What is it that they should be focusing on? So which of those 3 different types of quality should they be focusing on? And in particular, what should they be looking at when source code is deposited to ensure it is well curated? So again, this is another aspect of review here. So when source code is deposited, what needs to be reviewed and checked to ensure that it can be well curated and effectively managed by the repository? And then when you finished off that, and if we still have time, the last thing that we're looking for you to provide input on is what's the role of humans in this process? So can quality be assessed automatically? And if so, what type of quality and why? And we'll leave that question open, and I won't be kind of giving you a time limit on that. You'll be able to answer that question as you go on through other sessions, and it starts to kind of like gnaw at you, and you realize you've got an answer that you hadn't remembered. So we're just coming up to a few interesting answers here on the role of repository managers. So licensing is a very popular answer so far. There's a few people noting that ideally you do code quality, but that can be quite a big task. So unless it's machine computable, then it might be difficult to do. I think as we might expect, no one is putting in software quality because in some sense it is maybe outside of the remit of a repository manager to decide on that. Although there may be some highly curated repositories where the software quality and the functionality it provides may be assessed as well. So a lot of people are saying like accurate metadata. It would be interesting for those people to kind of for you to put in what you think is the kind of minimum for sorts of metadata for it to be well curated. Okay. And now there's some other interesting ones, certainly around documentation and what documentation needs to be deposited. And I think that's a really good point about what a repository will need to check in terms of the documentation that's provided alongside the source code. And I think the other one that I might pick out there is a really interesting one around language dependency and making sure it's that things are not necessarily language dependent. Okay. All right. I'll let you continue to fill that out. If you have any other things that you want to provide to us, this is really useful information, and we'll be publishing the sort of aggregated results of this as part of the notes from going forward from this. If you do have other things that have been raised as a result of this, please do kind of discuss this on the mailing list for the group. But for now, I'm going to hand back over to Moran to do a last set of bits in this session.
Thank you, Neil, and thank you very much for your presentation of the software citation implementation working group, and for this lovely workshop. I just wanted to say a little bit about the curation quality with this next slide, about what we did implement on the HAL archive, which is the National French Archive. This project started in 2017, where the INRIA Research Center, the CCSD, which is in charge of the HAL platform, and Software Heritage kind of joined forces to create this workflow where researchers can deposit software artifacts into the HAL platform, and there are moderators on the platform that kind of checks the curation quality, the metadata, to see if the content is actually software source code and not something else. It's not automated. It's not self archival deposits. So it's really verified, and also to check if the authors of the software, all the authors are specified in the metadata. So that's something which is very important to consider when curating the software, not to forget authors while depositing software. I'm going to ask Neil to move to the next slide. If you're interested a little bit more on this subject, you can go read there's a nice article about our collaboration on the National Archive. And for our software source code interest group, so we have 4 minutes left to kind of thank you all of your participation today on the collaborative notes. It's always impressive to see the participants engaged and really commenting the kind of work we prepared for them. So I'm really thank you for that. And so we have kind of your last work for today is to propose or upvote some of the themes that we have at the end of the document. That's on the next steps page. It's on page, this time, really 21 and not the false 21. So if you go there, you can upvote some of the themes that we already inserted. That was the themes that are already there were proposed on VP16. One of the themes we choose for today, which is the quality assessment theme, and we propose you the workshop. I hope that you enjoyed this subject. And also I'm going to ask for volunteers and for contributions for the next plenaries. If you want to, it's kind of a call for contributions if you want to present or help organize the session. I'm really happy to have you on board. So you can put your name, the role you want to do, an email if you're not on the mailing list. We are going also to do this kind of call of contributions before submitting the proposal, which might be 2 months before the session. I'm not sure exactly the timing, but we will do that on the mailing list just to kind of put the heads up. If you have something you want to share about software source code in this interest group on our next in the next plenary, this will be very appreciated on our part. So again, I want to thank you all, the participants for joining us today and really engaging in this session. And I also want to thank Roberto and Neil for presenting this lovely efforts that are around us, the CIRS report and the software citation implementation working group. There are so many things we want to talk about during this session, and we need to kind of limit ourselves. So thank you. If you have any other questions, don't use the chat because we have 1 minute left. You can use the notes, and I'm sure there's a feedback page on the bottom of the collaborative notes. You can put feedback or questions, and I promise you to answer everything and to kind of stay in contact with you. And for the questions that we didn't answer on the Q&A, we will get these questions from the moderators of the session, so we can answer them on the notes. And I am going to do an update to the mailing list with this with the notes link, and you can go back and read the answers for those questions which stayed unanswered. So with that, I'm going to tell you thank you very much and have a good end of the day and end of the plenary.
Thank you, Moran. Thank you, everyone.